In a little box within the archives of the Fremont Indian State Park Museum is an item labeled FIPR 17340. It is a small diorite pendant found within a structure identified as Pit House 57, excavated on Five Finger Ridge. It is only 3.9 centimeters or 1.535 inches in diameter, slightly larger than a US half-dollar. Within the box is a note identifying the pendant as a moonstone. Someone identifying the item clearly understood the lunar imagery on the pendant. There is a center hole in the stone surrounded by two crescent shapes, a smaller crescent on the left and a larger one on the right. Above and surrounding the crescent motifs are 13 circular depressions that have been carefully drilled into the pendant, and circumscribing the upper perimeter of the necklace are 19 notches. Most ancient peoples kept a lunar calendar. When closely observing the moon over the course of several years, certain hidden keys are revealed. Tracking the moon by its phases is the most common way to keep a lunar calendar. The moon goes through all its phases: new, waxing crescent, full, and waning crescent in 29.5 days. This means that after 12 such lunar months, there's a difference of 11.25 days for the solar year. Technically then, there are 12.37 lunar months in a year, but this fraction of a lunar month left within the solar year begins to add up with successive solar years. What it means is that every few years an additional lunar month must be added to the calendar to help keep lunar and solar counts in tune. And, as it turns out, to tune the moon and sun completely requires close observation over the course of 19 years. Indeed, if one observes the moonrise at a specific spot on the horizon at a specific time in a specific phase, the next time the moon will appear in exactly the same spot at the same time in the same phase is just short of 19 years later, 18.6 years to be exact. Here is a view of the eastern horizon from atop Five Finger Ridge in Clear Creek Canyon. From atop the ridge, one has an unobstructed view of the rising locations of both the sun and moon throughout the year. I have marked on this image the locations of where the sun rises during its annual course. It rises the farthest north on summer solstice, and the farthest south at winter solstice. Exactly between these points is where the sun rises on the days of equinox. To illustrate, on March 21st, the sun will rise at its equinox position. Every day thereafter, the sun rises further north on the horizon until it reaches its northern extreme standstill position at summer solstice. Then the sun stops its apparent northward motion, stands still for a few days, and then begins rising southward, making its way back to its equinox position by the fall equinox in September. The sun continues to rise southward until it reaches its southernmost standstill position at winter solstice in December. Here again, the sun stops for a few days and slowly turns back northward to repeat the entire yearly cycle. What the sun does in a year, the moon does in a month. Over 27.3 days, the moon goes through its sidereal cycle, rising across the horizon north and south, turning at its standstill positions just like the sun. However, because the moon's orbit around the Earth is tilted at 5.1 degrees from the ecliptic, something else happens with the moonrises on the horizon. The moonrise positions shift over time. The smallest domain of apparent risings occurs at least 5.1 degrees within the solstice positions of the sun. The actual range and measurement of where the moon rises during this period is also dependent on local latitude and viewing horizons. Where the moon rises at its extreme north and south locations is called the lunar minimum standstill, as the moon is within its minimum range of risings as it stops on the horizon, stands still, and reverses course. But over the period of about 9.5 years, the moon slowly drifts wider in its extreme standstill positions until it overtakes the sunrise positions of the solstices and eventually comes to a stop at its widest domain of apparent risings, at least 5.1 degrees outside of the solstice positions of the sun. Again, exact visual lunar risings are dependent on local latitude and the viewing horizon. The widest range of turning points for the moon is called its lunar maximum standstill. It takes another 9.5 years for the moon to return to its minimum standstill. Thus, over approximately 19 years, the moon rises across the eastern horizon every month, but its range of rising positions expand and contract as its turning points drift back and forth in relation to the solstice sun's position. In keeping a lunar calendar, the Fremont watch both the lunar phases as well as the position on the horizon of the lunar rises. As already mentioned, in order to calibrate the lunar calendar with the solar one, an extra 13th lunar month must be added to a lunar year 7 times over the 19-year period. So, for 12 years you have 12 lunar months, and for 7 years you have 13 lunar months. This entire cycle encodes a series of memorable numbers. There are 2 lunar positions to track, lunar maximum and lunar minimum standstills. 19 is the number of years required to track this cycle. 13 is the number of lunar months in your intercalary years and the number of lunar risings between monthly standstill positions. And 7 is the number of extra intercalary months needed to tune moon and sun together. Perhaps by coincidence, there are 7 notches carved above the 2 crescent images on the Moonstone. All these numbers are carved on this lunar pendant, and the Fremont Moonstone serves as a remarkable, complex, and yet simple memory aid. This lunar cycle is called the Metonic Cycle, named after the Greek astronomer Meton of Athens, who is the first in our history books who writes about it. But Meton is not the discoverer of this lunar cycle, as it is found in Babylonian and Chinese calendar systems. It is probable that it was understood in various cultures going back millennium. We do not know how many other Native American people tracked this 19-year solar lunar cycle. We do know, however, that the Anasazi of Chaco Canyon were fastidious about tracking this cycle. These people were contemporary with the Fremont. And, more tellingly, several pieces of turquoise found at Five Finger Ridge can be traced to the environs of Chaco, which means that there was cross-cultural contact between these peoples. In Chaco Canyon, the Lunar Standstill Cycle was recorded in two different ways. 1. The double spirals at the Sundagger site atop Fajada Butte caught the lunar light during its standstill phases. 3 columns of stone stand slightly at an angle and perpendicular to each other as they lean against a rock face. 2 large spirals are carved on the rock face. Sunlight and moonlight streams between the rock columns, forming shafts of light and shadow effects on the spirals. Sundaggers appear on the large spiral on the days of solstice and equinox, while significant shadow effects occur during the lunar minimum and maximum standstills. This is the only known site in North America where moonlight is captured on a petroglyph to calibrate the time of lunar standstills. In addition, the Chaco people recorded and measured the times and positions of lunar standstills in their pueblo constructions. In 7 different pueblos, the axis of construction line up to the lunar maximum and minimum standstills. One prominent example is Pueblo del Arroyo, where the lunar minimum standstill occurs in the center of an axis of open doorways framing the moonrise. Further, inter-pueblo alignments also show this lunar alignment. Chetroquetl is not only aligned to the lunar minimum standstill, but is also aligned to Quinbeneola and Pueblo Pintado. This triangle of buildings lines up with the moonset and moonrise of the same axis. The pueblo constructed at Chimney Rock in Colorado also appears to be built to observe the lunar maximum standstill moonrise. The Lunar Standstill Cycles, or Metonic Cycle, was extremely important to the people of Chaco. Yet, no other ethnographic information has confirmed that other Native American cultures tracked this cycle with such artistic or technical know-how. I contend that this assessment is about to change. The Fremont Moonstone shows that the Fremont at Clear Creek Canyon were also tracking this cycle. Further, we just might find, as at Fajada Butte, petroglyphs utilized in capturing the moonlight to help indicate this cycle. We will explore this possibility in part 2 of this series.